Hello my dear students and my dear friends. I welcomes to my YouTube channel. In this video lecture, I want to introduce a Fourier transforms which is under B.Sc. So under B.Sc, complete course I am giving in this one part 1. My dear friends, if uh, if you not subscribe my YouTube channel yet, please subscribe my YouTube channel as Hiranagara Manohar and like and share to your friends as well as write your comments on my comment box. So in the Fourier transforms, first syllabus introduction. We want to introduce syllabus. So in this Fourier transform, first one Fourier integral is there. Next complex Fourier transforms. Next inverse transforms, basic properties, finite Fourier transforms. Next transforms of the derivatives and the derivatives of the transforms. Next problems thereon. So next applications of Fourier transforms to ODE and PDE. This is about syllabus on Fourier transforms under B.Sc. So for this Fourier transforms, we want to refer this book, I.N. Sneddon McGraw-Hill's books. This is the best books for referring these Fourier transforms. Now in this topic, Fourier transform heading, first heading is Fourier integral. Fourier integral means let f of x be a real valued function which satisfies the following conditions. First one, two conditions are there. First one, f of x and f dash of x are continuous or have only a finite number of simple discontinuities, that is f of x and f dash of x are piecewise continuous in the interval open interval a comma b. That means f of x and f dash of x continuous continuous or have only a finite number of simple discontinuities in the open interval. So first condition, in this interval f of x and f dash of x are continuous functions. Both functions are continuous functions in this interval, that is piecewise continuous. That is first condition. Second condition, integral integral minus infinity to plus infinity mod f of x into dx converges. So integral minus infinity to plus infinity mod f of x into dx value converges. This is second condition. That is nothing but f of x is absolutely integrable in the interval minus infinity less than x less than infinity. So this one converges means this one integrable in this interval. So then it can be shown that if it is in converges, then it can be shown that that function f of x is equal to 1 by 2 pi into integral s is equal to one variable, I am taking s, is equal to minus infinity to plus infinity, and integral one more variable I am taking t is equal to minus infinity to plus infinity into f of t, one function, into cos s variable cos s of t minus x into dt into ds. Call it as equation number 1. So here the integral on the right side, this right side part is called what? Fourier integral or Fourier integral expansion of this function. This right side part is called Fourier integral or Fourier integral expansion of f of x. Okay, if it is clear, I will move on to the next topic, that is different forms of Fourier integrals. different forms of Fourier integral. First one, in these forms, first one, we have from equation 1, just now we discussed this equation. F of x is equal to 1 by 2 pi into integral s is equal to minus infinity to plus infinity. This one I am taking. Integral, one more interval t is equal to minus infinity to plus infinity f of t into cos s of t minus x into dt into ds equation. So in this equation I have splitted this both interval of these both functions. So see here 1 by 2 pi into integral 1 into 1 variable integral s is equal to minus infinity to plus infinity cos s variable at one place, cos s of t minus x into ds. See here all x terms at one place I am writing and all t terms at one place I am writing here, rewriting that first equation. That's all. So next we all know that integral minus infinity to plus infinity to f of x dx means we all know this form. Integral minus a to f of x dx value 2 times of integral 0 to a f of x into dx, when if f of x is equal to f of minus x. Here cos function is that this becomes f of x is equal to f of minus x. So that's why this integral minus infinity to plus infinity becomes 2 times of integral 0 to infinity to cos s of t minus x into ds. So into this term write as it is. This term write as it is. Next, this becomes here 2 get cancelled, remaining term 1 by pi into integral 0 to infinity. Now writing integral terms at one place. So integral 0 to infinity, one more integral minus infinity to plus infinity f of t into cos s of t minus x into ds into dt, call it as equation 2. This is one of the form. This is one of the form. Next, one more form. From this equation that will come. From this second equation that will come. Next form. So then we have just now derived this one. 1 by pi into integral 0 to pi into integral minus infinity to plus infinity f of t into cos s of t minus x into dt. Just derived. Here, for further next form, we are taking as a of s as integral minus infinity to plus infinity f of t into cos s of t. For our convenience, we are taking this value as a of s and this value, that means integral minus infinity to plus infinity f of t into sin s of t into dt value as taking b of s. Okay, now further we all know that this function, what will happen? We are simplifying this function. This value we are simplifying here. F of t into cos s of t minus x, we are simplifying. F of t value write as it is. Next, cos s of t minus x. That means cos st minus cos of st minus sx. We all know that this is nothing but cos of st minus sx. This is in the form of cos of a minus b form. Cos of a minus b form. Cos of a minus b form, we all know that cos a cos b plus sin a sin b form. Sin a sin b form. Under this form, this one. So instead of a is what? This is called a and this is called b. So apply, just replace that values. So this will come. So again rearrange these terms as f of t into cos s of t at one bracket into cos sx plus f of t, or multiply with f of t of this term. So That also write in one more bracket, f of t into sin s of t into remaining term sin s, sin sx. Thus we have this equation becomes f of x is equal to 1 by pi into 1 integral 0 to infinity, right, as it is. Next, this one integral minus infinity to plus infinity, right, as it is. This value from here to here, what will come? This whole thing. This whole thing we have to write here. F of t into cos s of t into cos sx into dt. Dt term is there here. Dt, see here, dt. Plus the integral minus infinity to plus infinity f of t into sin st into sin sx. See here, the sin sx for both term will come this sin sx. This sin sx for both term will come. So multiplying sin sx into dt into ds. So that becomes f of x is equal to 1 by pi into integral 0 to infinity. So this value is how much? F of t into cos st into dt value how much? A of s into cos sx, right, as it is, plus this f of t into sin tt integral minus infinity to, see here we are taking like this, integral minus infinity to plus infinity f of t into cos st dt value a of s. That one we are replacing here, a of s. Integral minus infinity to plus infinity f of t into cos st into dt value a of s. Remaining term here is that is cos s of t. Next, here integral minus infinity to plus infinity f of t into sin st into dt value is nothing but b of s. Remaining term write as it is, sin st into ds. Call it as this is equation 3. That means this is a form 3. Next, third form. This is very important. Cosine form. This is very important. Cosine form. Let f of t be an even function of t. That is, even function means f of minus t is equal to f of t. Then you say that is even function. Then f of t into cos st will be an even, and f of t into sin st will be an odd function of t. So when you are taking f of t be a even function, then this function f of t into cos st will becomes even. Then f of t into sin st will becomes odd. Why? Because this one even, this one becomes odd. So then a of s is equal to 2 times of this a of x becomes integral minus infinity to plus infinity becomes 2 times of, I am taking. So 2 times of integral 0 to infinity f of t into cos st into dt. Next, and this second term will become vanished. Why? Because this is a even function we are taking. So then equation 3 take the form as that, equation 3 take the form this one, b of s becomes 0. So that's why remaining term this one, 1 by pi into integral 0 to infinity s into cos sx into ds. So that's one, 1 by pi into integral 0 to infinity s into cos s into ds. Therefore f of x is equal to this one, replace here. So 2 by pi into integral 0 to infinity 1 integral 0 to infinity f of t into cos st into cos sx into ds into dt. Okay, in the, by replacing this value in the equation 1, we get this form. This is called cos form. Cos form is nothing but f of x is equal to 2 by pi into integral 0 to infinity f of t into cos st into cos sx into ds into dt. Observe carefully this one. cos st into cos sx. I am taking a c here. This is called cosine form. In the cosine, both are cos. Observe carefully. Cosine form of the Fourier integral. If it is clear, I will move on to the next one. That is, this is also very important. This is also very important. Sine form. Let f of b an odd function. So note, see here in this, we want to sine form means we want to take f of t as odd function. For getting cosine form, we are taking f of t as even function. Observe carefully. So then odd function means f of minus t is equal to minus f of t. Then f of t into cos st will be odd, reverse for cos form. F of t into sin st will be even function of t. So thus as is equal to 0 and bs is equal to 2 times of integral 0 to infinity f of t into sin st. So that's why this is a reverse form of cos form. Sine form is the reverse form of cos form. Briefly. So then equation 3 takes the form f of x is equal to 2 by 5 into integral 0 to infinity equation 3. See here equation 3. Here as value becomes 0. So that's why 1 by pi into integral 0 to infinity will becomes what? F of t into cos st into cos sx into ds into dx. This becomes 0 totally. Next, what will come? As value 0. This Vs value by As value 0 sine function, As value 0, Bs value apply, again simplify it on that third equation. So this form is called sine form of Fourier integral. Okay, this both s and vs value, first of all substitute in this equation 3 by substituting that s and vs value in this equation 3, and by simplifying that we will get these forms. Okay, if it is clear, I will move on to the next topic, next form, that is exponential form. This is also very important, exponential form. Consider f of x is equal to 1 by 2 pi into integral minus infinity to plus infinity, integral minus infinity to plus infinity, f of t into e power is into t minus x into dt into ds. So consider this function as f of x as 1 by 2 pi into double integral minus infinity to infinity f of t into e power is into t minus x into dt into ds I am considering. So then f of x is equal to 1 by 2 pi into double integral minus infinity to plus infinity f of t, right as this one exponential of is into t minus x we are expanding. So e power I theta is nothing but cos theta plus I sin theta. We all know that cos theta plus I sin theta. Like that, instead of theta, what is there? This one. Instead of theta, what is this? S into t minus s is there. T minus x is there. So that's why this one f of t, right as it is, cos theta. Theta is nothing but this term, s into t minus x plus I into sin theta. Sin theta is there. Theta is nothing but s into t minus x into dt into ds. Okay, just by expanding this exponential form. Then 1 by 2 pi into double integral minus infinity to plus infinity f of t into cos s into t minus x into dt. So this integral, by splitting these both two terms, plus I by, see here I is there, I by 2 pi into double integral minus infinity to plus infinity f of t into sine s of t minus x into dt into dx. We have splitted that for this term. That means multiplying these value into these two terms, we'll get this one. So this first integral is called, is the Fourier integral. That first integral is f of x as Fourier integral, and the second integral becomes vanishes as sine s of t minus x is an odd function. This second function will becomes 0. Why? Because this becomes add. This is odd, so that's why this will be vanish. So that's why we have only first term. F of x is equal to 1 by 2 pi into double integral minus infinity to plus infinity f of t into cos s into t minus x into dt into ds. F of t into e power is into t minus x into dt. This form is called exponential form of Fourier integral. First we are taking this form now. So that is called Fourier integral form. Fourier integral form. Fourier integral form. So sometimes that can be written as f of x is equal to 1 by 2 pi, just splitting s terms, exponential term at one place. This is ds. S terms at one place and t terms at one place. 1 by 2 pi into integral minus infinity to plus infinity e power minus isx into ds into integral minus infinity to plus infinity f of t into e power ist into dt. Okay, this is the one more exponential form. These are the different forms of Fourier integral. I will end of my this video lecture. My dear students, if you not subscribe my YouTube channel yet, please subscribe my YouTube channel as Tirinagara Manohar, and like and share to your friends, as well as write your valuable comments on my comment box. Thank you. Thank you, one and all. Thank you very much.